Good morning, everybody. Today, remaining part of trigonometry, we will start. So, types of angles. How many system of angles are there? So, angles are three systems. Angles we measure in three systems: hexadecimal system, centesimal system, and a circular system. Circular system or radian system we call. This angles today we are going to learn. So first is hexadecimal system. This is British system or English system we call. So angles are measured in three systems. Angles are measured in three systems. So what are the three systems? First one is hexadecimal system. Hexadecimal system. It is also called British system or English system. British or English system. So, okay, what is hexadecimal system? Hexa means 60. Hexa means 60. Hexa means 60. Hexadecimal system. Hexadecimal system means so dividing into 60s, multiples of 60s. So if you take a complete angle, so this is origin x, y, y dash, x dash. In this, if you take a complete angle, so it is 360 degrees. 360 degrees. 360 degrees. So one complete angle is equal to 360 degrees. In the hexadecimal system, one complete angle is equal to 360 degrees. Okay. So this is divided into four parts. Each part is one right angle, 90 degrees. So this is total four right angles. The combination of four right angles, the addition of four right angles, it becomes 360 degrees. That is complete angle. So 360 degrees. So the complete angle is divided into 360 equal parts. 360 equal parts. So each part is called degree. Each part of 360 degrees is called degree, 1 degree. So each part of 360, each part of 360 degrees is equal to 1 degree. Each part is our smallest part, or we can call each part of 360. Total 360, each part is called 1 degree. 1 degree is further divided into 60 equal parts. This is 1 degree now. So that is 1 degree itself very small. 1 degree itself very small. This is further divided into how many parts? 60 parts. 60 parts. So each part is called 60 minutes. It is denoted by simply dash. So 60 degrees is further divided into 60 equal parts. It is called minutes. Minutes. So all 60 minutes. Okay, clear? Further, each minute means smallest part, 60th part of this degree. So 60th part of this degree. Each minute is further divided into 60 equal parts, and it is called seconds. So 60 seconds. So this indication is called minute, and this double dash is called second. Okay. So in this system, everywhere they divided into 60s. That's why this system is called hexadecimal system, British system or English system. So one complete triangle is divided into 360 equal parts. 360 equal parts. Each part is called 1 degree. Each part is called 1 degree. And 1 degree is further divided into 60 equal parts. And 1 degree is equal to 60 equal parts. Those are called 60 minutes. And 1 minute is further divided into 60 equal parts. Those are called 60 seconds. This symbol indicates minutes. This symbol indicates seconds. This symbol minutes. This symbol seconds. Okay, clear? So copy it. Take a screenshot. Next system. Next, centesimal system. Centesimal system. This system is called French system. French system. So, in centesimal system, one complete angle. So, if we take a complete angle along with coordinates, x dash, y dash, it is the origin. So, in this complete angle, is divided into 400 equal parts. 400 equal parts. We call them as grades. So, complete angle is divided into 400 equal parts. Each part is called grade. So, each part is called grade, one grade. G is equal to, what do you call this one? Grade. So here, complete angle is divided into 400 equal parts. Each part is called grade. Each part is called one grade. Simply grade. Okay. Further, one grade is divided into 100 equal parts. Cent means 100. So it is divided into hundreds. So one grade is further divided into 100 equal parts. Here one grade is further divided into 100 equal parts. 100 equal parts. So, and it is called minutes. So this symbol indicates minutes. 100 equal parts, or we call 100 minutes. 100 minutes. Next, this smallest minute is further divided into 100 equal parts. These parts are called seconds. So 100 seconds. So 100 seconds. So this is your grade 1 your minute. This symbol, and double dash we call as second. So here carefully observe in this system. So grade is divided into 100 equal parts, and further it converted into minutes. 1 minute is further divided into 100 equal parts. Each part is called second. So that means their right angle is 90 degrees. Here right angle is 100 grades. So each right angle is 100 grades. Total, how many quadrants we have? 4 quadrants. Each quadrant makes 100 grades. So total grades is 100 plus 100 plus 100 plus 4 times means 400 grades. Is it clear? So it is centesimal system means cent means 100. Here cent means 100. So in examination you got 10% marks. 10%. Cent means 100%. Cent means 100. So in this system they divide angle in hundreds. That's what we call centesimal system. This is a French system. Next, coming to radian system or circular system. Is it over? Copy it now. Next, third part, radian or circular system. So in some books they call it as a Indian system. So what is this system? In this system, angle is measured in radians. Angle is measured in radians. So angle is measured in radians. It is denoted 1 radian. 1 radian it is denoted by 1 radian. It is denoted by simply 1 power c. In degrees 1 power 0. In grades 1 power g. In radians 1 radian is equal to 1 power c. Okay. Now definition of this circular system. What is 1 radian? So if we take a complete angle in a circle, so it is the center of the circle O. So now R is a radius. So next you have to take arc A, and arc length must be equal to radius of the circle. You have to consider arc AB such that whose length is equal to the radius of the circle. So radius always equal, both radiuses are equal, both radii are equal. So here radius, here radius. This is arc length. What is the arc length? Must and should be equal to radius of the circle. Radius of the circle. So now definition, see what is the radian? Radian definition. Definition of radian. Definition of radian. What is the radian? The angle made by an arc. This arc, AB arc. Imagine AB arc. The angle made by the arc, an arc at center, whose length is equal to the radius of the circle, is called 1 radian. Is called 1 radian. The angle subtended by, or the angle made by an arc whose length is equal to the radius of the circle is called 1 radian. Is it clear? So an angle subtended or made by an arc. That is arc means here AB we took arc made by an arc at center, at a center of a circle whose length means arc length, whose length is equal to radius of the same circle. Radius of circle is called, that angle is called 1 radian. 1 radian. It is denoted by 1 power c. Okay, radians are denoted by 1 power c. Okay. Next, what is the complete angle in the circle? If we take the complete angle, it is 2 pi radians. It is 2 pi radians. Complete angle in a circle. Complete angle in a circle. Complete angle in a circle is equal to 2 pi radian. Okay. Complete angle in a circle is 2 pi radians. So now 3 systems is over. In radian system, so we measure the angles in radians. Complete angle of circle is 2 pi radians. So angle in a semicircle is pi radians. Angle in a semicircle is pi radians. So right angle is equal to pi by 2 radians. So right angle is equal to pi by 2 radians. So that means 90 degrees is equal to pi by 2 radians, and 180 degrees is equal to 5 radians. 360 degrees is equal to 2 pi radians. Okay, clear? Next we will see some examples, conversion of this one. Now we will see the relation between these three systems. So complete angle in three systems we will see. Complete angle at the center of the circle. In degrees, 360 degrees. In grades, 400 grades. In radians, 2 pi radians. So relation between these three systems we will see. So degrees we denoted by d by 360 degree is equal to, next grades we denoted by capital G, grades, and radians C, 2 pi. Total we take 2 common. So this is, if we divide 360 and 400 and 2 pi by 2, we will get 180 here. D by 180 degrees, that is G by 400 grades, this is degrees grades, C by 2 pi radians. So now if you want to convert any angle into another systems, we can use this relation. So suppose if you want to convert degrees into radians, so see how to convert the degrees into radians. Suppose if I take a 60 degrees, angle theta is equal to 60 degrees. So you have to convert 60 degrees. So this 2 also goes if we divide with 2. This 400 also becomes 200. So divide with 2 all 180, 200 and 5 we get. So first we take 60 degrees. So what we get if we take 60 degrees here? Okay, let us see. So in the place of D, this is in degrees now, we have to write 60. So these two comparison we have to D by 180 degrees is equal to C by 5 radians. So in the place of D, I have to substitute the 60 value. So that implies in the place of D, whatever the angle given in degrees, that you have to substitute. So C by 5 radians. 0, 0, 6 1 ja, 6 3 ja. So send this pi this side. C is equal to pi by 3. So in radians, 60 degrees is equal to pi by 3. 60 degrees is equal to pi by 3 radians. That is 60 degrees is equal to pi by 3 radians. Here, like that, you can convert grades and degrees. So this is the degrees to grades, degrees to radians. So conversion of degrees to radians. Now radians to degrees we have to convert. Radians to degrees. How to convert angle from radians to degrees? Suppose if we take some right angle, or we can take 5 by 6 radians. 5 by 6 radians. Theta is equal to 5 by 6 radians. This we have to substitute in the place of C. So relation we know, this relation between these two we have to take. Compare these two. D by 180 degrees is equal to C by 5 radians. So here theta value we have to substitute at the place of C. So D by 180 degrees is equal to, at the place of C, 5 by 6 by pi. That means here numerator, denominator we have 1. It is reciprocal, it goes to upside. So D by 180 degrees is equal to 5 by 6 into 1 by pi. Pi gets cancelled. Send 180 degrees that side. So what we get here? D by 180 degrees is equal to 1 by 6 left there. No? D is equal to 180 degrees by 6. 6 1 ja, 630 ja. So therefore d is equal to how much you got? 30 degrees. So this is the conversion of radians into degrees. So 30 degrees is equal to 5 by 6 radians. Okay, clear? How to convert degrees to radians and radians to degrees. So this step you should remember, conversion of angle from one system to another system. There is a British system or English system to radian system or circular system. Here circular measure or radian system to British system or English system. Here copy this. Or otherwise you can take screenshot. Okay, clear? Next we are coming to next one. Next, conversion of degrees to grades and grades to degrees. So relation take first. This is the relation. You have to divide and take relation. Already we divided no? 200. Simplified. This is 5 grades. Okay. Grades, degrees. So now conversion of degrees to grades. So conversion of degrees to grades. Convert from degrees to grade. We have to take these two relations. First, suppose the angle we take theta is equal to 45 degrees. Theta is equal to 45 degrees. That we have to substitute in the place of degree. We are converting degree to grade, no? So take this relation. D by 180 degrees is equal to G by 200 grades. Now, in the place of D, you have to substitute the angle given in degrees. So 45 degrees you have to substitute here by 180 degrees is equal to G by 200 grades. So 45 1 ja, 45 4 ja goes. Okay. Now next step what we get here. So 1 by 4 is equal to G by 200 grades. Bring this 200 this side, goes to the numerator. It is in denominator, no, if you send that side, goes to the numerator. So G is equal to 200 grades by 4. So now cancel it. 4 1 ja, 450 ja. So G is equal to 50 grades. That means 45 degrees is equal to 50 grades. Any doubt here? Now conversion from grades to degree. Grades to degree. Grades to degrees. How to convert from grades to degrees? Let us consider one angle, one more angle. That is, we take some angle that is 30 degrees. 38, not 30. 30 means somewhat 90. 90 means 100 grades. 100 grades. G is equal to 100 grades. This you have to substitute. Theta is equal to 100 grades. This you have to substitute in the place of G. Take this relation. Again, you take this relation. D by 180 degrees is equal to G by 200 grades. So in the place of G, what we have to substitute here? We have to substitute G value. That is the angle, given angle. So 100 grades by 200 grades. 1 ja, 2 ja. 180 you have to send that side. 180 by 2 degrees. 1 ja, 90. So therefore, D is equal to 90 degrees. So therefore, 100 grades is equal to 90 degrees. Is it clear how to convert this one? So copy it. Next conversion, grades to radians. Grades to radians. grades to radians and radians to grades. So you take these two relations. Suppose if you take value grade G is equal to 300 grades. G is equal to 300 grades. Now relation you take. G by 200 grades is equal to C by 5 radians. At the place of G, we have to substitute this given angle. Theta is 300 grades now. So 300 grades by 200 grades is equal to C by 5 radians. So 0, 0 cancel, 3 by 2 left. Send this pi this side. C is equal to 3 pi by 2 radians. So that is 300 grades. 300 grades is equal to 3 pi by 2 radians. We converted grades into radians. Now radians into grades. Now we are going to convert radians into grades. So from radians to grades. So radians we take any radian. So what we are taking here? Pi radians. Theta is equal to pi radians. So this is we substitute in the place of C. Relation you take. G by 200 grades is equal to C by pi radians. So G by 200 grades is equal to C by pi radians by pi radians. Both will cancel, so we get 1. So G is equal to 200 grades will come. G is equal to 200 grades will come. So therefore, pi radians is equal to 200 grades. Okay, clear? No conflict. All methods over now. Degrees, grades, radians, and degrees, radians over, all over. No? Now, coming to some previous years IIT JEE mains or AIEEE previous years questions we will do. First question I will write. Okay, it is AIEEE previous paper 2003. The sum of the radii of inscribed and circumscribed circles for n side regular polygon of side A is, options are given 4 options. Now you take some regular polygon. We don't know how many sides it has. It is given n sides. So on. We don't know how many sides it has. So roughly I am drawing like this. Number of sides are given, n sides, so on it will come. And circle also, one circle is inscribed, one circle is circumscribed, and one is inscribed. 2 circles like this. So the sides we don't know, so on I am keeping. So n sides is given now, number of sides. So number of sides of polygon, number of sides of polygon, that is given n sides. Okay. Next, each side whose length is A is given. Clear? Now I am taking this part, this center and this part. So complete angle in this polygon at center is 360 degrees. 360 degrees. Or simply we call 2 pi. 2 pi radians. 2 pi radians. So n sides having is here 2 pi by n. This angle is 2 pi by n radians. So now we take that part 0, let it be AB. If you draw a perpendicular here to here, this capital or small or 2 radius we get. So now in this parts This is AB. This is perpendicular drawn. This is capital R, small r. So total length is A, and this is half of that A. Okay. This one D. Let it this be D. Clear? This part I drawn. Enlarge it. So this is radius of the circumscribed circle. This is the radius of the inscribed circle of a polygon. Okay. Now you see in this triangle, if this angle is half of this angle, 2 pi radians by n. Half of this angle is by 2, it becomes pi by n. So this triangle becomes pi by n radians. Pi by n radians. This angle also same will get pi by n radians. So now in that triangle it is right angle, opposite side, adjacent side, hypotenuse. Now I am taking sine of that angle. So in the triangle, ODA, angle ODA is equal to 90 degrees. Next angle AOD is equal to pi by n. So sine pi by n, opposite side by hypotenuse. What is opposite side then? Opposite side of this angle is A by 2. Hypotenuse is capital R. So A by 2 by capital R. So we have to find sum of the radii. So R, you have to find this. R is equal to A by 2 1 by sine pi by n. Okay, clear? Otherwise we can write this one as R is equal to A by 2 1 by sine means cosecant pi by n. It will become. Okay? Equation 1. Now this one will take equation. Next coming to this side. This side and this side relation, what do you get? So relation that will get cos. Cos we take. So cos pi by n, adjacent side by hypotenuse. R by capital R. R by capital R. Okay. So now this one become, you have to write small r as a subject. R cos pi by n. Cross multiply it. So next capital R value we are having already got, that is substitute. So what is the capital R value? A by 2. In terms of sine is substitute. It is better than sine. A by 2 sine 1 by sine. 1 by sine pi by n into cos pi by n. So carefully observe cos by sine. What is cos by sine? Cot. A by 2 cot pi by n. This is small r. So we got small r and capital R. Now add both. This is a capital R. This is small r. Equation 1 and 2. So equation 1 plus equation 2. What do you get here? R plus capital R plus small r. That is equal to A by 2 we have to take out from these two. Cosecant pi by n plus cot pi by n. From this we have to take out cosecant. Here 1 by sine having no. 1 by sine we take out. 1 by sine is cosecant. We take out cosecant. R plus R. So this will become A by 2. Otherwise we write 1 by sine pi by n plus cos pi by n by sine pi by n. Okay? LCM if you take what you get. So R plus R is equal to A by 2 1 plus cos pi by n by sine pi by n. Okay? So now we apply half angle formula. So what is half angle formula? We know that. We know that. We know that. So cos 2 theta is equal to 1 minus 2 sin square theta, or 2 cos square theta minus 1. 2 cos square theta minus 1. Now 2 cos square theta will become 1 plus cos 2 theta. 1 plus cos 2 theta. So now it is in the form of 1 plus cos 2 theta form now. So we have to write the half angle form of this one. So that will become next step. So right now we will do next step here. Okay, we will do next step here.